In the last couple of years, one of the main focuses of the National Institute for Earth Physics in Romania has been to obtain seismic risk loss estimations and also to give a proper image of how a major earthquake would affect the nowadays society. In the automation of the loss estimation process, a geographical information system representation became very useful in order to generate ready-to-use maps for emergency cases and a rapid assessment of the estimations. Part of the strategy for generating rapid response ground motion maps is to determine the best format for a reliable presentation of the maps, given the diverse audience: scientists, businesses, emergency response agencies, media, and the general public. In Romania, the strongest memory of a major earthquake goes back to March 4th, 1977. In that Friday evening, an earthquake with a magnitude of 7.2 on the Richter scale shook the country, producing significant damage. Based on the monitoring data, you can see here several common maps generated after the earthquake. The peak ground acceleration map, which measures the earthquake's acceleration through the ground. The peak ground velocity map, which provides the best correlation with damage, and the spectral response maps. In an effort to simplify and maximize the flow of information to the public, geologists use also the modified Mercalli intensity scale, which is based on interviews and damage observations to show how severely an earthquake was felt. The Mercalli scale uses Roman numerals from 1 to 12 to express shaking intensity. Another tool which reveals important information about an earthquake is the shake map. A shake map provides further information different from the earthquake's magnitude and epicenter, since this map focuses on the ground shaking produced by the earthquake, rather than the parameters describing the earthquake's source. So, while an earthquake has one magnitude and one epicenter, it produces a range of ground shaking levels at sites throughout the region, depending on the distance from the earthquake, the rock and soil conditions, and the variations in the propagation of seismic waves from the earthquake due to complexities in the structure of the Earth's crust.
După estimarea hărților de intensități, în cadrul Institutului s-a dezvoltat un program de analiză a vulnerabilității clădirilor în zonele specificate, astfel încât avem capacitatea de a analiza în timp real pagubele produse de un cutremur pentru localitățile din diferite județe, iar în câteva județe din sudul României avem o estimare a clădirilor publice.
Inițial, sistemul a fost gândit pentru cutremurele vrâncene intermediare, dar ulterior am putut observa aplicabilitatea acestei evaluări și la cutremure de alt tip, în special cutremure care au loc în Marea Neagră, zonă analizată și în cadrul proiectului ESNET.
On March 31st, 1901, an earthquake with a magnitude of 7.2 on the Richter scale occurred in the Shabla seismic area. It was the most powerful earthquake ever recorded in the Black Sea. Around Mangalia city in Romania, there were reported intensities of 9 to 10 on the Mercalli scale that had significant consequences. A 4-meter-high tsunami wave affected several coastal cities in Bulgaria and Romania.
Cutremurul analizat pe această hartă este evenimentul care a avut loc în zona Șabla pe 3 decembrie 2012, cu o magnitudine de 4,6 pe scara magnitudine moment. Poligoanele colorate în diferite nuanțe reprezintă nivelul la care se realizează analiza, fie nivel de oraș, cum este și în cazul orașului Constanța, fie nivel de comună. Pentru fiecare poligon în parte există o anumită culoare care reprezintă procentul posibil de clădiri care pot afecta locuitorii, rezidenții din aceste zone. La acest cutremur nu s-au înregistrat pagube, dar sistemul reprezintă anumite poligoane cu nuanțe colorate, deci este o estimare a vulnerabilității, nu o situație reală. Am realizat și o simulare a unui cutremur de 5,3 magnitudine. Încep să apară pagube mai semnificative. De exemplu, 2% din numărul total al clădirilor pot pune în pericol viețile omenești. În prezent, sistemul analizează județul Constanța din România și regiunea Dobrici din Bulgaria, dar pe baza următoarelor date de la recensământ vom putea extinde zona și vom putea adăuga și informații actuale.
The Republic of Moldova is located in an active seismic zone. The relative earthquake risk for the area was determined as a measure of the potential impact on the physical environment and exposed community. The aim of this study was to estimate the magnitude of damage and casualties expected in Chisinau city. To accomplish this, a simulation of earthquakes and damage to Chisinau city buildings was performed. The SNET project focuses on the earthquakes produced in the Black Sea region. In unlucky situations, these ground shakings can generate very dangerous tsunamis.
Institutul este punct național de contact pentru zona europeană privind alertare la tsunami pentru tsunamiurile produse în Marea Mediterană, Oceanul Atlantic, Marea Neagră sau alte mări conexe Oceanului Atlantic.
Tsunami Analysis Tool, in short TAT, is a program developed by the Joint Research Center for Analyzing Tsunami Events. It uses a similar concept as the earthquake early warning system and sets the alarm for any seism of magnitudes over 6.5 and below the water epicenters, which could easily lead to a tsunami. TAT analyzes seismic events in the Black Sea and worldwide. It is part of the Global Disaster Alert and Coordination System and estimates the height and the transmission time of a possible tsunami wave within just a few minutes after the detection of an earthquake. TAT registers in real time the level of the sea and represents an important tool in the tsunami analysis as it uses information from the Deep Ocean Analysis and Reporting on Tsunamis Network, the National Oceanic and Atmospheric Administration, and the Sea Level Monitoring Facility within UNESCO's program Global Sea Level Observing System. Earthquake simulations are proving to be useful for all parts concerned by this problem. The geologists and scientists can improve their monitoring tools in terms of information quality and speed. The authorities and the emergency response units can get a more accurate image of the risks and can find solutions for efficient interventions. The result? Ordinary people feel more secure and their property is better protected.